and welcome to 2.2 examples. So here is example A, finding an unknown percent. In the capture-recapture process, 200 fish were tagged. From the recapture results, the game warden estimated that the lake contains 2,500 fish. What percent of the fish were tagged? Alright, so what we need to do is we need to figure out what percent. So I know that some number out of 100 is going to be our percentage, right? And we want to say, what does that equal? Well, we say 100% is the total number of fish. So what is the total number of fish? Well, the game warden estimates that there are 2,500 fish total. So that's going to go where the 100 is. So we got 2,500 fish. And we say, what percent was tagged? Well, how many were tagged? So I know there are 200 were tagged. All right, so now I've got x over 100 equals 200 over 2,500. So what I'm going to do to make this a little bit easier is I'm going to cross out those zeros. So I can say that x over 100 is the same as 2 out of 25. All right, so then multiply both sides by 100, and I would get x equals 2 times, well, let's just do this, times 100 and times 100, right? And then I get 2 times 100 over 25, so it would be 200 over 25. And how many times is 25 going to 200? Well, how many quarters goes into $2? That would be 8. So we'd say x equals 8. So what percent of the fish were tagged? We could say 8% of the fish were tagged. All right, good. Example B, finding an unknown total in a lake with 250 tagged fish. Recapture results show that 11% of the fish are tagged. About how many fish are in the lake? So what we have to do is let's figure this out. Well, I'm going to do the percentage first because I know 11% out of 100. That works every time. So I like to do the percentage first. Okay, and then I have 250 tagged fish. And I know that is going to be in the numerator, so I'm going to say 250 because that is not the entire total number of fish. It's just a portion of it, right? And 11% is the portion, 250 is the portion, and I don't know how many fish are in the lake total. That's what I want to find. So what I'm going to do is I'm going to make the reciprocals. I'm going to take 100 over 11 equals x over 250. Now it should be more than 250. That makes sense because I should have more fish in the lake than I have that are tagged. Okay, so I'm going to take this and multiply by 250, and I'm actually going to write it over here because I'm running out of room. So I take 250 times 100, all is divided by 11, should equal x. All right, and then you get x equals, and we get 2272.72 repeating, and that doesn't make sense. I can't have a part of a fish, so I'm going to round to the nearest fish and make it 2273 equals x. And we're going to say about 2273 fish in the lake. Okay, again, we're estimating, so if we're not exact, that's okay. If you said about 2270, if you said about 2300, that would also be okay because we're kind of getting a lot of fish in here. So we say about 2300 fish, 2300 fish, that would be okay as well. All right, and then example C, a lake is estimated to have 5,000 fish after recapture experiments that showed 3% of the fish were tagged. How many fish were originally tagged? We're trying to find an unknown part here. All right, so let's see what we should do. So I see a 3%, so I'm going to take 3 out of 100. And I want to figure out, it said 3% of the fish were tagged. How many fish were originally tagged? Well, I need to figure out how many were in the original that were tagged. So I'm going to put T for tagged. We could put X, we could do a lot of things. And 5,000 fish total. All right, and then multiply by 5,000. So I get 3 times 5,000 is 15,000 divided by 100 equals T. And then get those out. I get 150 over 1. So I should have 150 equals T. So I should say that there were 150 fish were originally tagged. And there is the answer. All right.